Good evening and welcome to episode 6 of Elliott Astro-Imaging. Tonight I wanted to do a little short session again in regards to, as I thought tonight was going to be a little bit better for the weather, it chose not to. Looking at the finder, this is my view. And there is not much really to look at. As you can see, the clouds just rolling by. And I set up, it was crystal clear out there. Got it all set up, had a couple of friends on with me. Everything was going well. Got it all set up. Everything was focused, ready to go. And the clouds rolled in. So that put a damper on a few things. And since I've already got everything set up and everything's all ready, podcast, I figured, why not do one? Just a short, quick one for the processing of images. I did a crash course last week on how to process an image from an image session. And tonight I'm just going to go in a little bit more detail of showing everybody how to get certain things. And then you'll be able to go yourself as amateur astronomers, or you could just watch and see how cool it really is to start up, from an image, go from, frame to light frames. And I'm going to try to, I don't mean to use the word, but I'm going to dumb it down a little bit, understand what each term means, so everybody can understand and figure out from there. I do have all the files here. Pull it up for everybody. And the first thing we're going to do is we're going to pull up Deep Sky Stacker. Again, this is the stacking software that I use for stacking each image. And what it does is you can put the calibration frames in there, and that makes the image a little bit better. As I said, there's dust motes, there's just anything, in the image train, and you want to make sure that everything is as flat as possible. So we're going to add the picture files. Here, we're going to try to pull this up here. And we're going to pull them up from, we're going to do the Pelican Nebula from before. And what I did was I took, these were 6-minute images. They were 10 seconds short. I accidentally hit 5, but the image session already happened. So I was just under 6 minutes with these ones. And the other ones I took, these ones were 10-minute exposures. So, and you can combine them if need be. The way that I do it is I take the images and then I extract the red channel. And you extract the red channel when you're in hydrogen alpha, and that's the filter that I use. Hydrogen alpha is in the red channel of the wavelength of the light spectrum. And you will see a lot more detail when you're looking in the red channel. So what I'm going to do is I'm going to just take these ones right here, under the 6-minute ones. And you can see that they're black and white. And they're going to be black and white, but I've already processed them as what they need to be. And I'm going to use this here so you'll be able to see it a little bit better. I'm going to move the telescope control down here a little bit so you'll be able to see it. Okay. Okay, there you go. So now you can really see the Pelican, which is up here, the head, and then the beak, and then the eye, which is right there, and the North American Nebula, which is right there. So you can really see it. And what I do is when I go through these images, I go through each one individually, see if there's any satellites that went through them, and you can see a couple of them were better than others. See if there was no planes that went through these, and I already went through all of them that were 6 minutes. And then what I usually do is I go to group 1, and then you could do main group, group 1, and you can see that they disappeared. They didn't disappear completely. They're still there. I go to the 10-minute ones, and I put them in a different group. So you can see that these ones are here. So these ones are the 10 minutes. So you can see it's a lot brighter because it goes from 6 minutes to 10 minutes. So it's going to be a lot more data. So you'd have to try to adjust this here to get this to be a little bit darker here. And of course, you're going to get a lot more detail, which is really cool. And that's what you want, is you want more detail for the image. And you can see here, it's a lot smoother. It's a lot nicer. The stars are a lot crisper. You can see how the stars are pinpoint. And that's a 10-minute image. Guiding was running really well after the podcast, and everything was going really well. You can see on the corners here that they're a little stretched. That is because, one, I got to tighten it down just a tiny, tiny bit more. And two, I am going to need a field flattener for this camera and the telescope. And the field flat it actually flattens the image. So this way the center is perfect, and then it actually corrects it. So the corners are actually pinpoints, so you don't have to crop the image out and you lose some of the stars. So we got the main group and we got group one. So they're both there. So you can see the 6 minutes. And then what you do is you go to the dark files. So you want to load the darks. I have them under calibration frames. And you can see I have different cameras on here. Canon T3i is what we use at the BMO, which is the observatory. My Orion G3, which is the Orion Deep Space camera. And my QHY, which is the camera we're using for this one. And there's the ST9, which is the big one for the C14 out at the BMO, which is the Beaver Meadow Observatory. So we need to go to dark frames, and you can see how I have the two filters. I have hydrogen alpha. You want to go with hydrogen alpha, and you can see that I have them set. Now, I did 300 seconds. It should be 360. We're going to use these for now. Really doesn't matter, but it should be fine. And you can see I've already done the OSC. OSC stands for one-shot color, that's the camera, one-shot color camera. R is for the red channel, and so this way I know where they are, because you can see how these ones are uncalibrated. These ones are where it's extracting the red channel, so you're going to get more detail from that because it's a narrowband image. So you want to use these ones, so you're going to add them to it, so they add them as a dark frame. And then you want to go to group one, so you do the same thing. You go to dark, and it should already be there. So we're going to go up, and we go to 600 seconds, and we see I have 3 of them here, so we're going to add that. Okay, we're going to check all, and we're going to check all of those. So those ones are good. And then we go to flat files. So we go back to astronomy, then we go back to calibration, and we go to frames, which is here, again, hydrogen alpha. And I have the regular the flat frames that are uncalibrated, and then I color, which is what I want. I've already looked at every single one of these. Sometimes it'll back out, as in like for the pixels. So you might get a bad image here and there. So you actually have to look at these individually to make sure that nothing went bad. So those are set. So we're going to use that for the flat. But I'm going to go over detail with what each frame is, so this way everybody knows what they are. Light frames are what we take. As you can see, this is the object here. So it's uncovered, shooting the image at a certain time, whether it be 300 seconds, which is 5 minutes, 360 seconds, which is 6 minutes, or the 600 seconds, which is 10 minutes. And the dark frames is your telescope. So your telescope is covered shooting at that exact time. So if I shoot these at 10 minutes, I need 10-minute darks. And it has to be the same time what it was out on there. So I got those. The flats, which is down here, as you can see here, the flat frames are, I have a light panel, an LED panel, which is used for artist sketching and for tracing. And I have it wall, and I point the telescope at that and have to get a flat field image where the history. So you have the flats, you have the darks, and you have the lights. The next thing you need is bias frames. I know, of course, with the bias frames is you take it as the shutter speed you possibly can do. Okay, the fastest shutter speed that your camera will allow you to do. And for this one, I think it was 1/10,000th of a second. So it is super fast, and it's with the telescope covered. So you put the cover back on the telescope and you shoot those ones. So you just add those on there. And of course I extracted the red from, so you'll be able to see the bias frames at the bottom here. So everything is checked, everything is good. Here. So then the next thing you do is you look for the best image you can find for stars. And you just go through each one. Now, of course, I've already stacked these so you can see that the score here, so you can see that the actual score is good, whatever it may be. So I'm going to just maneuver here. One more. There we go. And you can see that the stars in this one are a little off. So we're going to use the next one here. I might just use the 10-minute image here. Yeah, we're going to use the 10-minute one because I think that one was by far, the guiding was just so pinpoint and dead on. It's the 10-minute image. So another thing I like to do is I like to actually take and get rid of the artifacts that you actually have when you're posting these images. So I like to get rid of the black. So you can see that I take a border around it so it'll stack everything. So for instance, if the star moved like 2 or 3 way or 2 or 3 pixels that way, it'll actually move the image and cut out the edge. The edge you do not want, especially when you're trying to pre and post process the image. When you're trying to do levels, because it will factor in that black on the outside or white, depending on what you're doing. So you don't want that to have it. So what you do then is you go to register and check your pictures. So you want your already registered pictures, your automatic detection of hot pixels, and you're going to want to do 80 to 90. I'll do 85%. And then you can see that your darks, your flats, and your offset bias frames are checked. It's in green. If one of these were missing or you did not have them, it will turn red and it will let you know that you're missing a frame. And just like the crash course, what I was telling everybody is to the star detection threshold. You want, as I said before, you want to get between 40 and 50 stars. And so we're going to bring it down to 10%. Okay, bring it down. I would say 8. 8 would probably be good. And we'll try 7. Okay. So we're good with that. Go to recommended settings. Again, I don't like to really touch anything. Everything is in great shape. Everything is good with that. So hit OK. Stacking parameters. Now, I use the custom rectangle. So when you use the custom rectangle, as I said, you use that little red box and you put that around there. This will be checked. So all the images that you take are within that. If you're looking at it with the white box, the green box, and the white box here, if you're taking multiple images all nights and you don't exactly get that image dead center, it will center it for you. But again, there's artifacts on the outside. So just be aware of that. And again, a drizzle, I don't like to do it. If I'm running 6 or 7 programs at the same time, it will eat up a lot of RAM. So I'll just leave it as is. And again, I like to keep median kappa, median, everything's perfect, automatic for the alignment. Everything is good with that. You keep everything here. Cosmetic, you like to keep the hot pixels and the cold pixels. Everything is perfect with that. And the output is perfect with that. So you hit OK. So then what it's going to do is when you hit OK, then it reviews it, tells you what you picked from step 1 all the way to the end, and then tells you how much processing it's going to take and how much you have free, and then you hit OK. So this will go through super fast. Now, my notebook, this would probably take 25 to 30 minutes. This will take probably only 2 to 3 minutes total, and it will whip through these images super fast. So I'm going to talk a little bit while it does that, and I'm going to just describe it. So what it just did was it took all the flat frames, the dark frames, and then the bias frames, and added them to every single image that's on there. So it took the 20-some-odd images that I had and then registered them, took the best of those 20, and now is stacking the 11 final image. So it actually went fast. That's how fast it is. It's great. It's awesome. I love it. So now the image is done. So now you're going to look at it and say, well, that's not really a good image. It's dark. Well, where's the nebulosity? It's bad. What I do is you look down here at the bottom, you can see that there's a little bump right here, a little gray bump. And then you have this line that looks like a little S curve. What you do is, as I said before, you want to get that little bump at about 33%. So you want to move it to about right about there. Okay, so then that makes it right where you want it to be. Again, like I said in the last episode when I was doing image processing, each person's different. If you want to mimic me, great. If you want to do your own, hey, that's fine too. However you want to make your image, that's the best. So you go to the darkness, and I like to crank the darkness as much as possible. And when you crank the darkness, as you can see, the actual S makes it more of an S curve. It actually goes down, and that's fine. That's what you want. Again, the next thing that you go to the midtone, and you like to get a little bit more detail. So you want to get it, as I said, between 5 to 8 degrees. And then you want to move this over so that way that S actually goes right where that bump is. And then for the highlights, you want to try to get as much highlights. You don't want to crank it like this, as it's going to get really bad. So you want to get it down to like just a nice medium curve. So really, really nice. And then you just hit apply. And then you'll be able to see the actual image and how cool this image looks, and the detail, and that the little circles that you saw in that flat, you do not see it in the actual image. And then you could just play with it and try to get it to be exactly where you want it for lightness, for darkness. You know, if it's too much, you can change it to get it to be exactly where you want it. So it's different. I like this. This is what I call pre-process. So you're processing it, and you're actually, playing with the histogram before you actually take it over to Photoshop. Is where the magic really happens. And looking at the stars here, I am very, very impressed. The stars are pinpoint. And 11 frames, and it took some of the 10-minute exposures and took some of the 6-minute exposures, or if you want to get technical, 5 minutes and 50 seconds. And it actually turned out really well. It actually turned out really, really well for a pre-process. And then what I do is you go to save to picture file. You just want to go and you just type in anything you want. You could type in Pelican, because it is the Pelican Nebula, and you hit save. And it is saved to cloud. So I'm not really going to be doing much more tonight, as a short little session just to see how everything is and see how everything turns out. I did show everybody the finalized image on that, which turned out really, 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 really awesome. And the next few nights, I'm going to try to add more to this. Get some more 10-minute exposures on this. Get some more 6 minutes on here. And then eventually, towards the end of the summer, is I'm going to do this in color too. Get the stars, take the hydrogen off, and then use the sky glow filter and get the actual colors of these stars. Mask the stars. So in other words, take the stars out of this image completely. Use this as red. So any gray that you see will be red. And then put the stars back into the field, but actually use them in color. So you'll actually get the natural color of the stars and the natural color of the nebulosity. So it looks a little bit more detailed. Red channel for this, so it shows more detail of this, and you'll be able to get more of the gray. If you were to do this just as a straight shot of not extracting the red, it would just look cluttered, and it doesn't look. Post an image on the Elliott image Astro-Image, and you'll be able to see it from there. But more going on tonight, so I'm going to end the broadcast for tonight, and tomorrow looks sort of okay. It's not going to be great, but it's going to be okay. From 10 to about 2 a.m. looks decent. However, tonight looked decent too, and it changed. So we'll take it for what it's worth. I'm going to let everybody know by about 4 or 5 p.m. tomorrow night, right around that time, of what the weather is going to be like. If it's going to be great, I'm going to get out here to about 9:30, and we'll start a broadcast between 9:45 and 10:15. If the weather's bad, as I said, I'm going to try to see if I can get CS3 on here, and I will run the next process of processing an image. So again, I'm going to end the broadcast. I want to thank everybody for watching, and have a good one.